Thank you very much, Johannes. I'm very honored to be here to accept this award on behalf of myself, but as well as my co-authors, Thomas Tenkate and Sheelagh Carpendale. When we did this work, we were all actually affiliated with the University of Calgary. I was a PhD student there, Thomas Tenkate was a visiting researcher, and Sheelagh Carpendale was a professor. Since then, we've actually all moved to new locations. I am currently a professor at the University of Waterloo, and I direct the Touch Lab there. Thomas Tenkate is working on his own game development studio called Frozen Fractal after having spent some time at Google as a developer. And Sheelagh has actually recently moved, in case some of you don't know this already, to Simon Fraser University from the University of Calgary. That happened this November. So we're now all in new locations. And before I get into this talk, I want to kind of reflect a little bit and mention that I'm going to reuse a lot of the slides that I used from back then, but I'm also going to try and put it into context and describe, what was the state of the art at the time, and what are some possible opportunities for next steps from this kind of work. But hopefully, by the end of this talk, I'll be able to once again leave you with the message that providing rich multi-touch manipulation of 3D objects is sufficient to enable virtual objects to be used in meaningful ways as tools. These virtual tools can also allow a 3D tabletop environment to act as a fully functional application. And so as I mentioned, I'm going to try and put this into context a little bit. And so in order to do that, I actually have to take you about 20 years into the past. And so this work was really heavily inspired by work by Underkoffler and Ishii on their urban planning system called ERP. And in particular, unfortunately, the video is old and difficult to see here, but you can see that this is really where tangible computing started, I think. And they looked at this idea of having physical objects interact with the table. And in particular, one of the things they talked about quite a lot was how can these objects take on a wide variety of different meanings. And I'm actually going to come back to this axis that they introduced, but the kind of key point to take away from this is that there's a lot of different things it can do. For instance, it can act like itself, and so that's sort of the center of this axis, the noun type version of it, that the building there can act like a building. But if you go to the right, things can actually take on sort of action-like meanings, and so verbs and reconfigurable tools can also be used in different ways. If you go to the left side of this, it's really the properties of those objects that matter. So things like their color or shape or something along those lines. And that can somehow be used to interact with the technology in some way. And so fast forward a little bit more in time, so 10 years later, that's sort of when this paper was introduced. And actually at this time, while multi-touch technology had been introduced back in the 80s, we hadn't really had the technology that was available to make it practical until around this time. And so things like the Microsoft Surface and the iPhone and technologies like this had just been released on the market. And so there was this kind of big surge in a lot of multi-touch technology. And what that let us start to think about was how can we now start to really interact with objects beneath that table. And so I was building on some of the work that I had recently published at Chi called Shallow Depth 3D, where I was looking at how to move and rotate objects in 3D on a surface. And so here you can move and rotate using 3 different fingers on a table. And this was sort of a new idea at the time where you could use multiple fingers rather than just using one. And so here you can do things that were kind of a little bit more complicated, like build something like a 3D pyramid. This one had flags on it that were kind of weirdly shaped. But really the idea, and actually a lot of other papers were using the same kind of idea, is that there was a hand that was detected by a flat surface, and that flat surface translated it into points of some kind. And then there were objects underneath that surface that were controlled via those points. And so really it had this sort of separation that all the physical stuff happened above the table and all the digital stuff happened in the table. And the layer in between was the table that provided the input to that technology. And then a year after that paper that I just mentioned, this work by Andy Wilson and his colleagues at Microsoft Research really kind of opened up a new idea of, well, what if we actually take the input from these technologies and use it as input to a physics simulation of some kind? And this enabled using touch much like you would with a physical object. So a lot more like this kind of ERP type system. And so the idea here is instead of having the digital stuff being separate from the physical stuff, you sort of integrate that idea where the physical stuff actually becomes part of a physics simulation in the digital table. And so this was a really neat idea that I wanted to build off of. And so here, with both of these kinds of systems, actually, the physical connection to the visuals was much closer than it used to be. And so another aspect of these kinds of systems was that the way that you interacted with the technology was a lot more realistic than it had been in the past. But there were still some problems that we needed to address, of course, because I have a paper that we're going to talk about. And so the first problem was that there was really no way to lift objects up. There were some techniques at the time to do this, but the physics example didn't really have a way of doing it. So when you moved your fingers around at the time, all you could do was use it like a physics engine. So lifting wasn't possible. And another one was that when you have this sort of physics engine, you actually kind of give up some of the control that you have when you're using this point-based interaction. And so the physics engine has a little bit more ability to control what's going on. And so what this paper was really about was trying to think about, well, how can we get the best of those two worlds? And the idea behind this all is really thinking about that surface as being an intermediary where you can use the object that you're controlling like a tool to control other objects in that environment. And so here we still have this sort of physical and digital divide, but the thing that you're physically controlling is now a tool that can interact with other objects in this sort of physical way. And so you still have that kind of multi-touch control, the higher precision type control, but you still also have a physics engine. So that really what happens is that the things you're controlling end up being these sticky tools, things that stick to your fingers that then can control other things. And I think the best exemplar of this kind of idea is this video that I made back 10 years ago, where I basically used a parody of 2001: A Space Odyssey. And so I'll show that video again. So at the end, I'm trying to show that we can get rid of the mouth. Thank you. So you can see it's a good thing that I didn't take up acting. Instead, I went into academia. And so really, I thought of this as being the idea of it's the dawn of digital tables, right? Just like in the 2001 of Space Odyssey, it's the dawn of man in that case. And really, it should be human. And so the idea here is sticky fingers and opposable thumbs was this idea of having that sort of precise control over the objects. And so it's very similar to the three-touch technique I introduced, but we added the ability to lift. And so what that looked like was this. So essentially, you could move objects around by just using one finger, or any number of fingers actually, and then dragging it across the display. So this is not any different than the previous technique. And to rotate objects, you could actually use two fingers and then twist them. But then to lift, you could actually still have your fingers stick to that object. And so by spreading them apart, that actually lifts them in the 3D projection that we're using on the table. And then sort of to relax the idea of it being sticky, there is this idea of opposable thumbs. So if you actually want to flip this object over, which you can't really do if your fingers are stuck to it, then you can use the third finger, which we call an opposable thumb, to while you're holding onto that object, rotate it in the other two dimensions. And so with that gives you kind of these full 6 degrees of freedom of movement. And then the next thing that you could do is attach a physics engine to this. So then when you're moving and rotating an object around, when it interacts with other objects in that environment, there's actually a physics engine there, and it'll bump into them and it'll move them around. And so that's the idea of sticky tools. And so really sticky tools is just this combination of sticky fingers, opposable thumbs, and then virtual tools that are really just like a physics engine based thing. And so the idea here is now we have this kind of way of doing force-based interaction through objects into a table. And so to exemplify this a little bit more, so we have the ability now to have people control physical objects to control physical objects. And this is really just what we get for free because we're in a physical environment. And just to emphasize this a little bit more, this isn't actually the slide I used before. This is actually my daughter. Before I used a random YouTube baby. But the idea here is that children from a very young age learn to use physical objects. It's a really important part of their cognitive development, actually, and it means that later in life, we now have this sort of familiar interaction with the physical world. And we know that when you drop things on other things, what will happen. And when you attach things to other things, they attach in certain ways and twist and so on. I just wanted to kind of point this out because a lot of us talk about this kind of thing as being intuitive, but it's really something that is a learned kind of behavior that takes a while, though it is also part of our cognitive development and is pretty fundamental. But we also now have the ability to do things like having people control virtual objects and also physical objects controlling virtual objects. And so this is the kind of two things that I mentioned before that predated this work, where you can actually physically control through a display, a table, or you can have physical objects on top of that table to control the virtual space itself as well, with tangible type computing. And the thing that's kind of being added with this work, or was added with this work, was the idea that virtual objects can control other virtual objects. In a physical-like way, I should say. And so that's what kind of that realization I had when I was a PhD student sitting in my office there. That physical or virtual things can also control other virtual things in this kind of physical way. And so what that allows is for us to think about a different kind of interaction vocabulary with how to work with these physical-like components. And so the claim here is that these sticky tools can allow virtual objects to take on a richer set of meanings. And so the meanings that I'm going to use here are very much all the way back 20 years before now with the ERP system. And so we can move towards this kind of full functionality in an application without the need for additional techniques like gestures or menus if we have these virtual tools interacting with other virtual tools. To demonstrate this, we had an application called sand tray therapy. And I won't go into too much detail about what this is, but the important parts to know about it are that it's a type of therapy that's actually used with children very commonly, where they play in a sandbox and the therapist observes that play, and it begins a kind of conversation that they can have around whatever the child is there for the therapy for in the first place. Because children aren't very good at sitting on couches and talking about their feelings. And so using this kind of sandbox-like thing is a good way to get them to engage in therapy. And I'm going to come back to this kind of spectrum of meaning that was introduced by Underkoffler and Ishii a while ago. And so the center, as I mentioned, is really the important starting point of that axis. And it's where an object really represents itself. And so they have a long description of what that means. But the thing to take away is it's really that objects are fully literal. They're representations of themselves. So a teapot is a teapot and a dinosaur is a dinosaur. And so here in the sanitary therapy application that we had a drawer that was full of objects that could represent themselves. And so here a pumpkin is a pumpkin, or actually, sorry, a bowling ball is a bowling ball, and the pins are pins. And if you throw the bowling ball into the pins, they react just like you would expect. And so it's sort of this literal interpretation. It's the most kind of mundane one of these things. But if you move a little bit to the right on this axis, it starts to be about the actions. And so verbs are really about representing an object as just what act it can do on the world. And again, there's a long description that Underkoffler and Ishii had, but the idea is that the object works to act on the world in some way. And so here, an example of a verb would be where you have a cloth-like object here, for instance, that has the color orange, and if you drop it, do the action of dropping it onto other things, then it can recolor that object. Another example is if you want to change the time of day, and so this is really similar to what Underkoffler and Ishii did with the buildings. You can change where the shadows are by moving an object, a light bulb object's position. And then if you go even further to the right, you can have completely reconfigurable tools where the action is the only thing that matters about them. And so here, this is much more like you're fully abstracting things away. This is kind of like a GUI component in an interface. And so you can still do that kind of thing with this sort of physics engine. And so the way that you can do this is we had a resize drawer. So if you wanted to change the size of this hawk to be a really giant hawk, you just put it in the drawer and then use a little dial, which is this reconfigurable tool that then changes the size of that object. You can do the same thing with the elephant to make an elephant that's really tiny. And notice that you could actually use any property here. So you could change the height of an object, you could change the color of an object, you could change any kind of property about it. It's really just a completely reconfigurable tool. And then if you go to the left side of this axis, it's more about the properties of that object. So an adjective is really a descriptor of something. And so an example of this is really we're thinking about the attribute or the properties of that object. And so here we had another drawer on the other side of the table that let you recolor the background. And so the only thing that matters about each of those buckets is whether it's water, whether it's sand, whether it's grass, or whether it's pavement. And what it can do is send water through the hose so that you can paint that background, or send grass, or send sand, or whatever you want. So the shark can now swim in water, and the lion can be in a field, and the cactus can be in a desert. And so really it's just the property of those objects that let you interact with that environment. And then if you go all the way to the left, it's really this idea of an object being just a pure object. And so you don't actually necessarily even need to care about any aspect of that thing, just the fact that it's an object matters. And so really the way that Underkoffler and Ishii talked about this was that an object is knowable as an object, and that's all that really matters. And so I think the best example of this is the idea of saving something into a random object. And so here you can create a scene, and so this is sped up a little bit so you can see how that might happen. And then if you want to save that scene for later, you can save it in the dinosaur. And so notice that that kind of sentence sort of has an unusual structure, but the meaning of it is still meaningful. And so here, as I mentioned, this is a mock-up. I'm reusing the resize drawer, but we did implement this later with a drawer at the bottom. But if you put the dinosaur in the drawer and hide it away, then later when you come back, you can reload the scene by dropping the dinosaur back into the scene. And so really all that matters here is that the dinosaur is an object. Doesn't matter which object I used. Any of the objects could have saved the scene. And so really the idea here is that the ability to use virtual objects along this entire spectrum of meaning allows us to move towards a more fully functional application that can use 3D multi-touch interaction. And so more specifically, these sticky fingers and opposable thumbs, together with the use of virtual tools in this physics engine, provide the basis for this entire spectrum. And by the way, it doesn't really have to be this specific interaction technique. It just has to be an interaction technique that allows this kind of thinking about the entire spectrum of meaning. And so now I want to talk a little bit about, so where has the work gone since this kind of the Sticky Tools paper? And so 3D Touch since 2009, there are actually too many to talk about, so I'm just going to pick these three. But there have been a lot of people who have done a lot of great work on 3D interaction, and I think have better interaction techniques than what I had introduced at this time. And so these examples here show that actually if you use things like handles on an object, you can do much more precise and much quicker, higher performance type interaction with 3D interfaces. Martin et al. Noticed that there's no video for this one, but I wanted to mention it. Did a comparison of the 3-touch-like techniques with ones that separate out the rotation and the translation. And that turns out to be a much more efficient way of interacting with 3D technology. But this came after the paper that I'm mentioning today. But there's also been some work that has talked about how do we actually do this kind of 3D interaction when you have a stereoscopic like vision of that technology. And that's a bit of a harder problem because then when you touch the table, sometimes it might appear as though your finger is through the objects. And so lots of people have had creative ways of solving that problem. And so we've actually come pretty far since this work in 3D interaction. But I still think there are a lot of opportunities available for future work based on the kind of work that I introduced about 10 years ago. I still think there's very little work on this idea of using virtual tools. And so yes, we've done a lot of work on 3D interaction techniques. And yes, we also have things like widgets. But widgets are a little bit different than this idea of having something that's a grabbable, physical-like tool to control other artifacts in that scene. And so I think we could think a little bit more deeply about how can we make interfaces that really engage with this idea a bit more. And more specifically, we could think a little bit about how could we use this sort of sticky tool idea in other domains. And so, for instance, thinking about things like virtual, augmented, or mixed reality, what does it mean to have a tool that can interact, a virtual tool that can interact with other tools? Can we potentially have better interaction techniques by thinking about it like that? There's also a whole area in information visualization called constructive visualization that looks at how do you use physical objects with data? How can you have data be represented physically? And again, I think we could maybe think about, well, we could come back to the digital world as long as we think about that data as a more physical-like thing, and that could be an interesting direction to go as well. But in general, with all those new domains, I think we should start thinking a little bit more about what's the meaning that we can take on with these virtual tools. And so think about not only how efficient your technique is, but can it take on the meaning of nouns, verbs, adjectives, tools, and pure objects. If it can do that, it might be more powerful in a different way than just performance. And so I hopefully have once again left you with the message that providing rich multi-touch manipulation of 3D objects is sufficient to enable virtual objects to be used in a meaningful way as tools. And that these virtual tools can allow a 3D tabletop environment to act as a fully functional application. And so thank you once again from myself and my co-authors.
Thank you, Mark. Any comments, questions? Please go ahead. Oh, okay. So let me start. Sure. Slide 14 was my favorite, but can you go back to slide 13?
Oh, sure. Whoops. Okay, I'll just do 13. Yeah. Yes.
This is a slide from 2009, right?
No, actually, I made this one.
Okay.
I hacked it together, yeah.
Okay. Because I was wondering if you could comment on that, if this is still true. I think this really reflects our view on multi-touch interaction. Back then, 2009, it was all about natural user interfaces. The UI elements behaved like objects and not longer as, widgets or things like that. So it was all about physical interaction. But is that still true, or have we moved in a different direction? Because as you noted at the end of the talk, there are not really sticky tools out there we use, and this idea of physical interaction maybe moved a bit into the background. So I was just curious to hear your thoughts.
I completely agree that there's the direction that people have gone has much more been let's focus on making a new interaction technique rather than thinking about how do we integrate this idea of a tool. But I think there's still a lot of opportunity for that. So I wouldn't say it's true or false. It's just that it hasn't yet been done still. I think that a lot of the work that I have focused on even since this is on this idea of embodied interaction. And I know that people think of embodiment sometimes as being like this avatar type embodiment. But what I mean is more like the pen type embodiment. And so when you can use a pen and then forget about the pen. And I think if we want to get into what we call natural and intuitive, which I don't think are good words to use, we really should be looking at how can we actually integrate with the technology, have it become part of our body. And I think that's a better way to think about it. And I think tools, physical ones, do that very well. And still the digital ones, they can do it. I think even, for instance, mice, we can think of as being part of our body. But at the same time, they're not quite as physically integrated. And so I think there's some really interesting work that can still be done there. Yeah. Thanks for the question.
Hi, that was a really nice talk. I'm actually wondering how you think the metaphors change a little bit when you have both interaction on top of the surface, maybe using robots, or other different types of toys, anything which can be kind of moved, and also interaction that's happening on the tabletop itself.
Yeah.
Can you talk a little bit about that?
Yeah, and so I think that that's a really great question. I think that the idea of that under Koffler and Ishii introduced a while back, as I mentioned, really did have that sort of tight integration of physical objects with virtual things. And what we were looking at here was really just if those physical-like things are within the surface, what would that be like? And so I tried to stay just with that idea. But I really like the idea of it being more a kind of spectrum of things where you can have both the physical things and the virtual things being physical, and have a physics simulation that then has the physical things and the digital things working in unison. I think that's a much better idea, but I think we shouldn't ignore the possibility of becoming integrated with those things in the table as well as the things that are above the table. So thanks for that question.
Thank you.
Hi there, I'm Oliver from the Affective and Cognitive Institute of Offenburg University. And when I look at your work, I think it's really already, although it's quite a few years ago since it was done, it's very timely, and it could be actually used. I also happen to be director of a gaming company, which I founded. And when I look at my designers, or also the students whom I teach, when they're working with digital models, they have such a hard time of focusing, using the mouse. So did you ever talk to a vendor of a 3D software like Autodesk, which is right over here, to sort of create an IDE where your solution, which to me seems very far advanced already, could be an IDE for an Autodesk software, for example?
Right. So actually, the work that I just presented here, Smart Technologies later patented and integrated into a tool. I don't know if they've actually sold it publicly, but they definitely have access to it. And so I do know that there was interest at the time. And so, yes, in a sense. And also, by the way, I mentioned briefly the application of Santre therapy. We have another later paper that talked a little bit more detail about how we use that with Santre therapists. Because it was sort of a participatory design with the Santre therapists. And it is possible to use it to do a type of Santre therapy where people can actually get a therapy type of meaning out of it. And so that's why that meaning side of it was really important. Yeah. But I think, again, there's still a lot of opportunity to do more. Yes, so thank you very much. I'm glad you think it's still relevant. And actually, another thing about what you're saying there, I think that many people have cited this work, but when they do that, they often are talking about the lift idea that was introduced in this paper. But I think that they don't often talk about the tool idea. And I would like to see more people referencing that side of it and seeing if they can integrate that into their own work. So if you're looking for a project to do as a PhD or master's student, please think about looking at that sort of future work.
Okay, great. Thank you, Mark. Now back to the future, back to 2018. Thanks again for